5. Okay, so review. Yep. 1, 15, 19. Okay, square roots. So these are on your quiz. These are on your final. So perfect squares. If you don't know your perfect squares, 4, 9, 16, 25, 36, 49, 64, 81, 100, blah, blah, blah. Okay, these are the perfect squares. So we're going to reduce square roots. These are the numbers we're trying to get, okay? So right back, 12. 2 and 6, no. 4 and 3. Square root of 4, square root of 3. Square root of 4 is 2. There is no square root of 3. 2 square root of 3. That's it. Done. Okay? Number 2, 48. Now there's a lot. You can do 4 and 12. 4 and 12 will work, but 16 and 3 is better because it gets you the answer quicker. I'm going to go 16 and 3 because 16 times 3 is 48. I'm going to take half my exponent. I'm going to get an x to the third. Square root of 16 is 4. X to the third. Square roots of 3. That's all we got to do.
Wait, can we reduce 4 more to 2?
Great question. Is there a square root of 4?
Yeah.
No, there's no square root. Okay, ready? Square root of 16 is 4. Plain old 4. Plain old 4. It's just the number 4. There's no square root of 4, is there? So I took the square root of 16. Square root of 16 is 4. Okay? All right, number 3. I'm going to break down 18 into 9 and 2. I can't take half of this. I need to take half of this, so we're going to rewrite this as square root of x to the fourth, square root of x. I take 1 away to make it even. Take 1 away to make it even, okay? Because I need to take half of it. I don't want to take half of 5 because it gives me a decimal. So I take 1 away and make it a square root of a fourth power and a first power. So now 3. I'll take the square root of 9 is 3. I'll take half of this. Half of the 4 is x to the 2. Now, square root of 2 is an ugly number. Square root of x can't be done. These 2 are left over. They stay inside.
I have a question.
Yep.
So for the square root of 16, or on the last problem,
Yeah.
why do we only put 1 4?
Great question. Square root of 16 is plain old 4 because 4 times 4 makes 16.
But then for the 9, for the square root of... Oh, never mind. There's a 3 by... Okay.
Got it. Okay, so I got a 9x squared, square root of 2x. Okay, good question. How am I doing?
Good.
Okay, number...
Hold on.
Okay, all right. Okay, number 4, there's no plus or minuses. We're just going to multiply. Regular numbers, whole numbers with whole numbers. I get a 10, square root numbers, square root numbers, square roots of 18. Now, we can break down 18. 18 can be broken down into the square root of 9 and the square root of 2. So 10, square root of 9, square root of 2. Square root of 9 is 3. 10 times 3 is 30. Square root of 2. Okay, that's it. 5 is actually really easy, but we have to look at it as 2 separate square roots. I got the square root of 36.
6 over 7.
Yes, over the square root of 49, which is just 6 over 7. Yes. Yeah, that's it. Actually should be one of the easier ones. Don't let that one confuse you, okay? Now 6, we get the problem. Okay, it's a silly rule, but it's a math rule. You can't have a square root in the denominator. Okay, so we fix the problem with the problem. Fix the problem with the problem. The problem is square root of 5, so we multiply by the square root of 5, square root of 5. Okay, the reason that helps is because on the bottom we'll get the square root of 25, which is 5. But I will do that. We'll get 3 square roots of 5 over the square root of 25. We'll multiply 3 square roots of 5. Square root of 25. But the square root of 25 is plain old 5 on the bottom. So I get 3 square roots of 5 over 5. It's a dumb rule. I didn't make it, but it's a rule that you can't have a square at the bottom. We don't. Okay. 7, I'm going to need some graph paper to graph this. Okay. So I'm going to get out my graph paper.
Oh, in space.
There we go. So before I start, I know the vertex is at, guys, stop talking. Torin, Hannah.
Lauren, stop.
So my vertex is at positive 3, negative 4. Okay, that's where my vertex is. Opposite. Okay, so let's graph this. All right. Okay. All right, I'm going to graph this. And I'm going to have a vertex at 3, negative 4. Okay, now, it's a parabola. It's a parabola. So, listen. 1 squared is 1. 1 squared is 1. 2 squared is 4. 3 squared is 9. So, remember how we do this? We start our vertex, we go over 1. 1 squared is 1. Back to my vertex. I go over 1, 2. 2 squared is 4. 1, 2, 3, 4. Go back to my vertex. I go 1, 2, 3. 3 squared is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I know that because it's a parabola, it has a line of symmetry that goes right down the middle through the vertex. And then I will reflect my points to the other side of the line of symmetry.
Wait, but how do we find the line of symmetry?
It goes right through the vertex.
No, I mean, how do we find the vertex?
It's opposite of that. See, it's in vertex form.
Oh.
It's in vertex form, right? Remember vertex form?
Yeah.
So I'll have another point here. I'll reflect this point, and I'll reflect this point. And I'll draw them in. Okay? So, it's in vertex form. I don't need to do the negative b over 2a. So, and I'll show it just so you guys see the difference, okay? If I had something like this, y equals, say, x squared, say minus 4x plus, or minus 5. This is what we did yesterday. If it's in this form, you've got to use the negative b over 2a, okay? That's standard form. This is what we did yesterday. If it's in this form, x squared plus a number, right? You have to use the negative b over 2a. But if it's in what we call vertex form with the parentheses, vertex form is nice because you don't have to do any work. The vertex is just opposite of that, 3, negative 4, okay? Both forms give you a vertex. Vertex forms gives you the vertex the easiest way, right? Okay. All right. Moving on. Find the zeros of x plus 2 quantity squared minus 9. Now the zeros, what we got to do is this. We got to solve. We're going to solve for x. Okay, and Zoe, you ready?
Yes.
How many answers?
2.
Okay, everybody agree? 2 answers?
Yeah.
Got to have 2 answers. Have to have 2 answers because it's an x squared. So let's solve. Well, the first thing I'm going to do is just go plus 9, right? Plus 9, plus 9. So I'll have a parentheses x plus 2 squared equals 9. Okay? To get rid of the square, we're going to square root. But like Zoe said, we have to have 2 answers. So I'm going to be a little bit careful. I'm going to square, to get rid of the square, I'm going to square root. Square root. Now the square root of 9 is 3, but it's also negative 3. So we're going to go plus or minus 3. This is where it gets a little tricky, but we need 2 answers, right? We need 2 answers, so I'm going to say x plus 2 equals plus or minus 3. Now why plus or minus 3? Well, listen. 3 times 3 is 9, right? 3 times 3 is 9, but negative 3 times negative 3 is also 9. That's why you get the both answers, right? Now, I'm going to have 2 mini equations. So I'm going to go, I need 2 answers, right? So I'm going to go 2 equations, okay? My 2 equations are this. I'm going to go an x plus 2 equals 3 and an x plus 2 equals negative 3. That way I'm going to get my 2 answers. That's my plus or minus 3. That's how I'm going to get my 2 answers, okay? So I went x plus 2 equals 3 and x plus 2 equals negative 3 because of the plus or minus 3. Now I'm just going to solve. Minus 2, x equals 1. Minus 2, x equals negative 5. There they are. One of the harder ones, but you guys can do this, especially if you have these notes, right? So you go through your notes on Thursday and say, hey, Mr. Davies did one of those. All I have to do is follow along and I'm good to go, okay? Okay, ready to turn the page?
Yes.
Okay, I'll wait for you. No, it's okay. You guys good? I'll wait for you. Okay, turn the page. Okay, now, all right. Simplify. All right, this is easy. Now remember, when we multiply, we're going to add, write yourself a little note, we're going to add exponents. Because we're going to multiply. We're going to go that times that, that times that, that times that. We're going to distribute. We're going to add exponents, okay? So 12x to the third minus 6x squared plus 15x. That's it. All right. Okay, number 10.
Oh, wait, that's it?
That's it.
Yay.
This shouldn't be hard. And that was said so well. We've learned a lot of math, haven't we? That's an easy problem, isn't it? Yeah. Okay. Now, it's a fraction, right? It's a fraction. So we're going to reduce our whole numbers. Okay? 18 over 6 is just plain old 3 over 1, or 3, right? Now, 2 of these x's cancel 2 of these x's, right? 2 of these x's cancel 2 of these x's. And I'll write up here, it's kind of like this. X cubed over x squared, but cancel, 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 and then all would be left over is 1x on the top, right? Right? One of these y's will cancel one of these y's. So I'll be left with this y to the third on the bottom. One of these y's would cancel one of these y's, so we'll be left with y to the third on the bottom. That's it. Okay. 11. Now, if you have negative exponents, we're going to need a fraction. Okay, we're going to need a fraction because of the negative exponent. Okay, I'm going to have a negative exponent, so I'm going to need a fraction. So I'm just going to make my fraction bar. Anything that has a negative exponent needs to be moved. So I'm going to move this y to the third down. Okay, I'm just going to move it down. Anything with a negative exponent, move it. Move it up or move it down, but you got to move it to make it positive. Now the 5 is just a regular 5. I'll leave it where it's at. The x to the third is a regular old positive x to the third. Leave it where it's at. Now the z to the 0 is 1. Anything 0 power is 1. Okay? And finally, I could leave it like that, but 5 times 1 is just 5. I mean, I could, but you guys agree 5 times 1 is just 5. I'm just going to go 5. I don't even know. You didn't even have to write that, do you, Julia? Smart girl. You're like, what's the point in writing it, right? 5x3 over y3. That's it. Okay? All right. 12. We are going to go 4 to the third, x to the 15, nope, to the 9, my bad. Okay, 4 to the third, x to the 9, y to the 15. So I'm multiplying exponents. Okay, multiplying exponents. Okay, 4 to the third is 4 times 4 times 4.
64.
It's 64.
Oh, yes. 27.
64, x9, y15. Okay? All right, now, 13. We're going to start doing a little geometry. In fact, tomorrow is going to be all geometry stuff. So, 13, let's slide this up. So I'm going to graph it. Okay, I need a perpendicular bisector. Easiest way to get it is to graph it, okay?
Oh, I did it. Good one.
All right. Last problem, we can get this done. So 4, 4 is A. 1, 2, 3, 4. 1, 2, 3, 4. There's A. Negative 4, 0. 1, 2, 3, 4 is B. So first thing I'm going to do is just graph it, okay? Just going to graph it. Draw my line. Okay.
Negative 40?
No, it's negative 4 comma 0.
Oh.
Okay. Now, to be a perpendicular bisector, okay, it's got to go through the middle. So we've got to find the midpoint and at 90 degrees, okay? Okay. So we got to go through the midpoint. So let's find the midpoint first. So to find the midpoint, I think it's right here, but I can walk it. Pretty sure it's here, but I can walk it. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. So if I want the middle, the full journey is over 8 up 4. But if I want the midpoint, it'd be halfway, which is half the journey. So instead of 8, 4, let's go 1, 2, 3, 4, 1, 2. So there it is. So my midpoint is really at the point 0, 2. Okay, so now I know the line's going to look something like this, right? It could be 90, something like this, right? So to make it 90 degrees, I need the opposite slope. Right? So the slope of AB is up 1 over 2, up 1 over 2. So the slope of this one is up 1 over 2. So the perpendicular slope has got to be the opposite, which is down 2 over 1. In fact, it kind of makes sense. If I do my, okay, so the slope of this one's up 1 over 2, right? To make it 90 degrees, make it perpendicular, we're going to have to do the opposite slope. So instead of up 1 over 2, let's do the opposite, which is down 2 over 1. Let's check it out. Down 2 over 1, down 2 over 1, 2, 1, 2, 1. That looks 90 degrees, doesn't it? It really does look 90 to me, right? Okay. So that's the line I want, but I want the equation of that, okay? So let's see. How do I do the equation line? Equation of a line. We're going to use our y equals mx plus b, right? Remember that? We're going to use our y equals mx plus b, right? So I'm going to go for this line right here, the equation of that line. It's going to be y equals negative 2 over 1x plus 2. Okay, that's a little bit harder, but I have faith you can do it on Thursday, okay?